Let us see the vector diagram of three-phase transformer. We have seen the phasor group. So in phasor group 1, DD0 and YY0. We have seen YY0. So let me take DD0. DD0 means HV winding is in delta and LV winding is in also delta, and phasor difference between them is 0. So if I have to draw HV to neutral, it is vertical, and LV to neutral is also in phase, right? Keeping this in mind, I will draw the phasor diagram. In delta we don't have neutral, but I can consider imaginary neutral. So as per the convention A to N, we have seen convention that HV side A to N is always vertical. So A to N is vertical, and HV side phase A will be brought from terminal A2. So A to N is vertical, and the A phase will be brought from A2. So I will write here A2 to A1 will be here, okay, and B2 to B1 for delta connection, and it will be C2 to C1. So this will be HV side. This terminal will be named as A terminal, it will be named as B terminal, and it will be named as C terminal. This is A arm, B arm, and C arm, right? And VAB will be this VAB voltage, that is line voltage in delta, will be this one. And LV side A to L is also vertical, so LV side A to N is vertical, and it will be drawn. A to A1 will be in parallel with this one, so it is A1, right? This will be B to B1, and it will be C to C1. This is A terminal, B terminal, C terminal, A arm, B arm, and C arm, and this is what VAB, secondary line voltage. So what we are seeing, primary line voltage and secondary line voltage, they are in phase, which you can see here VAB. This is VAB and VAB. So phase difference between them is 0 degree, and winding diagram or winding connection will be, I have three windings on primary, three windings secondary. These are the dots: A2, A1, B2, B1, C2, C1, and here these are the dots: A2, A1, B2, B1, and C2, C1. So A2 is connected to C1. A2 will be connected to C1, so I can draw it. It is connected to C1. Then A1 is connected to B2, so A1 is connected to B2, and B1 is connected to C2. And these terminals are brought out. They will be terminal A, terminal B, terminal C, right? And here A2 C1, so A2 C1 is connected, A1 B2, A1 is connected to B2, B1 C2, so B1 is connected to C2, and these are the terminals of secondary side, C, B, and A. So in YY0 and DD0, what we have seen, that phase difference between primary and secondary line voltage is 0. Line voltage is 0 degree, right? Let us go for second group, that is YY6. Zigzag DZ0 is not included in syllabus, so let me sorry, go for next group, that is YY6. So YY6, we can see here HV to neutral is vertical upward, and LV side is at 6 o'clock, so LV side will be LV and neutral, right? So keeping this in mind, let me draw first HV side. So A2 A1 or it is neutral also, will be vertically, and B2 B1 will be drawn from here following phase sequence. It is B2 B1, and we will have C2 C1 here, C2 C1, and this terminal will be A terminal, this will be B terminal, and this will be C terminal. This is A arm, B arm, and C arm and A to B or B to A, VAB is the line voltage. Now for drawing LV side, what we are seeing, that LV side is at 6 o'clock, right? So 6 o'clock, so, and it is LVT neutral is shown here. So for LV side, we will have neutral here, but the terminal must be brought from A2 only. So it is what, A2 A1, right? Now B2 B1 and C2 C1. So A2 A1 and AR is in parallel with A. B2 B1 we can see it is here. So it must be drawn from the tip of this and parallel to this. So parallel to this we will have line in this direction. So it will be what, B2 B1 and C2 C1 parallel to this, and this is BR parallel to capital V. C2 C1, so C2 C1 will be parallel to this, and it will be shown here C1 and C2, and this will be CR. So this is how we can go for the YY6. It will be B terminal, it will be A terminal, and it will be C terminal, and VAB will be now directed to, we can see terminal A is here, so VA will be here. So what we are seeing, VAB primary line voltage and secondary line voltage, the angle between them is 180 degree. They are out of phase, right? Opposite to each other. About connection diagram, so I will have again 3 windings, and here also 3 windings. It is what, A2 A1, B2 B1, C2 C1. A1 B1 C1 are connected together, so I will connect them, and this will give us neutral of HV side. It is A2 A1, B2 B1, C2 C1, here A2, B2, C2, you can see A2, B2, C2, they are connected together to make neutral. So neutral is here, they will be connected, and these terminals will be available like this. These are what? A, B, C terminal, and these are A, B, C terminal of LV side, right? So this is what DD0 connection. Now, sorry, YY6. Now let us go for DD6, delta 6. DD6 connection. So here again HVT neutral will be upward and LVT neutral will be at 6 o'clock. So this is what LV to neutral, right? So let me draw first HV delta. So imaginary N, A2N, and A2 terminal will be here. So and A2 A1 will be drawn like this. Then B2 B1 following the phase sequence, B2 B1, and it will be C2 C1. This will be named as A terminal, B terminal, and C terminal. Arms will be A arm, B arm, and C arm. Secondary side is at 6 o'clock. So neutral will, imaginary neutral will come here, and it will be it will start from A1 right? So A1 A2 must be parallel to A. So A1 A2, it will be A1 and this will be what? A2. This is A arm. B1 B2 must be parallel to this, so it will be B1 B2, and C1 C2 will be parallel to C1 C2, C1 C2, right? Now here it will be A terminal, it will be B terminal, and it will be C terminal, and VAB will be in this direction. This is B arm, this is C arm. So what we are seeing, and VAB in this is, so VAB, HV side and VAB LV side, they are out of phase, right? 180 degree. VAB and this is VAB. Winding diagram can be drawn following connection here only. So these are the A2 A1, B2 B1, C2 C1 dots, and here A2 A1, B2 B1, C2 C1. A2 C1 is connected, so A2 C1 will be connected like this. It will be A2 and it is connected to C1. Then A1 B2, A1 B2, and B1 C2, and these terminals will be taken as ABC terminal, right? A terminal, B terminal, and C terminal. Now what we are seeing, A1 is connected to C2, so A1 is connected to C2 here like this. A2 is connected to B1, so A2 is connected to B1. B2 is connected to C1, so B2 is connected to C1. So, and these terminals will be available on secondary side. Okay, so this is what DD6 and YY6 connection. Now coming to next YD1 connection. So here HV to neutral is vertical and delta LV to N will be at 1 o'clock. 1 o'clock will come here. So it is what? LV and neutral. So first let me draw star. A to N is shown here and it is A1 also, and this will be B2 B1 and it will come as C2 C1. Terminal A, terminal B and terminal C. This will be A arm, B arm and C arm. These are helpful arms. Naming arm are helpful to draw LV side phasors. Now delta and fictitious neutral will be there. It is at 1 o'clock. So this is neutral and at 1 o'clock it will be somewhere here, right? And it will come from A2. So this is A2, this is 12 o'clock, this is 1 o'clock. So 30 degrees there, phase difference, and A2 locus is available. Now A2 to A1 must be parallel to A arm. So it is perpendicular. So A2 to A1 is drawn here. B2 to B1. So this is B2 to B1. It will be parallel to B arm. So this will give us B2 to B1 and C2 to C1. So parallel to this I will draw line here, C2 to C1, and this will be A terminal, B terminal, C terminal, A arm, B arm and C arm. Now VAB. So VAB is this voltage and VAB here is this one. So what we are seeing, VAB, so this angle, it is at 12 o'clock, it is at 1 o'clock. So this angle is 30 degree. That means line voltage of secondary lags, I can say secondary line voltage lags primary line voltage by 30 degree, right? In connection diagram, so this is winding diagram. A2 A1, B2 B1, C2 C1, and here A2 A1, B2 B1, C2 C1. A1 B1 C1 are shorted, so it will be shorted and it will be neutral. And here A2 is connected to C1. A2 is connected to C1, so A2 is connected to C1. A1 is connected to B2 and B1 is connected to C2. And these will be available as terminals like this. So these are the terminals A, B, C, A, B, C, right? Let us go for DY1 connection. DY1, mind you, delta and star connection, so delta always follow star, right? That means in this case LV winding will be drawn first, and based on LV we will find the locus of all arms, A arm, B arm, C arm, and based on that we will go for the HV winding. And what is LV to neutral? That is known to as HV to neutral is here, and LV to neutral is at 1 o'clock, right? So instead of drawing delta, I will draw first star. So that is LV winding. So let me draw star. LV to neutral is at 1 o'clock, so I will draw it at like this. So this is what? A2 to neutral. That is A1 also. This is locus of A2, A1. Then B2, B1 will be somewhere here. B2, B1 and C2, C1 will come here. This will be A terminal, B terminal and C terminal. It will be A arm, B arm, C arm, and this will be VAB voltage, right? Now I have to go for delta, and A2N is neutral. A2N must be vertical. So here I have imaginary neutral, and this is what A2. Now where to go? For that we have this phasor. So A2, A1, that means A2, A1 in HV side must be parallel to this arm, and parallel to this I will have this one, A2, A1, right? This is C2, C1. So C2, C1 will be parallel to this, and I will draw here C2, C1, and parallel to this B2, B1 will come. So parallel to that, parallel to this line, this is the line. It is B2, B1. This is A terminal, right? This is B terminal, and this is C terminal. And this arm is A arm, which is parallel to this LV side. This is C arm, and this is B arm, and this voltage is VAB. So VAB is here, and VAB here also. LV side voltage will lag HV side by 30 degree, and winding will be A2, A1, B2, B1, C2, C1, A2, A1, B2, B1, C2, C1. A2 is connected to B1, so A2 is connected to B1, B2 is connected to C1, B2 is connected to C1, and A1 is connected to C2. And these are the terminals A, B, C. Similarly, here A1, B1, C1 are shorted. So A1, B1, C1 are shorted, and that becomes neutral, and A2, B2, C2 are coming as the LV winding terminals. Now let us go for next connection, that is YD11. So LV winding is, sorry, HV winding and neutral is vertical, and LV winding neutral is at 11 o'clock. So angle will be 30 degrees. So let me draw this star connection. Vertical, it is A2 to A1. That is also neutral. This will be B2 to B1, and this will be C2 to C1. The terminal will be A, B and C. Arms will be A arm, B arm and C arm, and this will become VAB, right? And delta, as it is at 30 degree, so from this is fictitious neutral, and this will be A2. From A2 I will go for A1. A2 must be parallel to A arm, so A2 A1 is drawn here, Now B2 B1 must be parallel to this, so it will be drawn like this, B2 B1, and it is BR, and C2 C1 must be parallel to this, so it is what, C2 C1, and this is CR. A terminal, this will be B terminal, and this is C terminal. So this voltage will be VAB. What we are seeing, this slope is more than this slope, and scenario is like this. This is VAB, and this is secondary line voltage VAB. Angle difference is 30. That is, secondary line voltage leads primary line voltage by 30 degree, right? And winding diagram will be A2 A1 B2 C2 C1 B1 A2 A1 B2 B1 C2 C1. So here A1 B1 C1 are shorted and it becomes neutral, and these are available as HV winding terminals A, B, C, and in LV side A2 is connected to B1, so A2 is connected to B1, sorry, it is connected here. A1 is connected to C2, so A1 is connected to C2, and B2 is connected to C1, right? And terminals A2, these terminals are available as LV winding terminals A, B, C. Let us go for DY11. HV to neutral is here, and LV will be at 11 o'clock. Mind you, delta is followed by star, so I will go for star first, and star is at 11 o'clock. So this is A2N, and it is also A1 terminal, and if it is A2 A1, B2 B1 will be here. This is, sorry, these are small letters because we are drawing LV winding, B2 B1, and we will have here C2 C1, right? This is A1 also. So this terminal is A terminal, this is C terminal, and this is B terminal, and AB terminal will give us VAB. This is A arm, B arm, C arm. Based on this, I will go for HV winding. So A2 neutral, that is vertical. Now A2 to A1 I have to draw. This is what A2, and A2 A1 must be parallel to A arm. So parallel to this I have here A1, and this is A arm. B2 B1, so B2 B1 and will be drawn parallel to this B arm. It is B2 B1, and this will be C2 C1. This is B arm, this is C arm, this is terminal A, terminal B, terminal C, and this voltage is VAB. So if we compare this line voltage with this, secondary line voltage is leading this by 30 degree. So this is VAB, and this is secondary line voltage 30 degree. And winding diagram can be drawn. A2 A1, B2 B1, C2 C1, A2 A1, B2 B1, C2 C1. LV side A1 B1 C1 are shorted, so it will become neutral, and in HV side A2 is connected to C1, so it is connected to C1. A1 is connected to B2 and B1 is connected to C2, and these are the terminals, right? This is A, B, C. These are HV winding terminals and these are LV winding terminals A, B and C. So that's all for Phasor group and vector diagram of three-phase transformer.